When we talk about a three-phase balanced or three-phase unbalanced system, we must first know a very basic thing. That is, it is not the source that decides if a system is balanced or unbalanced until the winding of the source generator is placed wrongly, which is a very rare case. It is the load which decides if a system is balanced or unbalanced. Now let's understand what is a balanced system. As we know, in three-phase system, phase voltages or current are displaced from each other by 120 degree. This is because the winding of a generator are placed 120 degree apart from each other. Consider a star-connected windings as shown in the figure. Now, if you connect load to it, we can call it as a system. Let's say we connected an equal load on each winding. As the load on my system is identical, current flowing through each phase is same. And hence, phase angle between voltage and current is perfectly 120 degree apart from each other as shown in the figure. Also, if your load is perfectly identical on all the three phases, current flowing through the neutral is also zero. If you observe the diagram carefully, you will find that the sum of return currents is zero at every instance. For example, at instance corresponding to 240 degree, IC is equals to maximum and IB equals to IA is equals to minus 0.5 Imax. So if we add these return currents, we will get the sum equals to 0. And this is true for every instance. And hence we can say that there is no current flowing through the neutral, and we can actually remove the neutral conductor from the circuit without affecting the voltage and current. This is only applicable for perfectly balanced system, that is system with identical load on each phase. And we can call such system as a balanced system. So what are the properties of a balanced system? Waveform is perfectly sinusoidal, that is in terms of magnitude and phase shift of 120 degree. Current flowing through each phase is same. No current flows through the neutral. Power loss is very low or not present. Of course, such system is ideal and existence of which is doubtful. Most of the system are unbalanced, like our distribution system. And the properties of unbalanced systems are completely opposite of what we have seen just now. Now let's increase the load on one of the phase of our system. As we have increased the load on one phase, it will draw more current than the other two phases. And this will create imbalance in the system. And here you will need the neutral conductor. The waveform is now disturbed in terms of magnitude and phase shift. This will further cause the power loss in the system. Generally, the system gets unbalanced because of these reasons. Unbalance in winding of a three-phase equipment like three-phase induction motor. If the reactance of the three windings are not same, then it will draw unequal current from the system. And the second one is unequal load on the system. This causes more current to flow through one particular phase on which the extra load is connected. These are the two main and the basic causes of unbalance in a system. Such kind of unbalance causes heating of three-phase machines. Further, this will decrease their overall life. This imbalance will also increase the I2R losses. Also, unbalanced system may cause tripping of variable frequency drives used for induction motor. You will see in our distribution system, a neutral is always provided, as load on the phases is not defined or equal, and the different phases draw different current, which makes the distribution system unbalanced. Let's check out the properties of an unbalanced system. Waveforms are disturbed in terms of magnitude and phase angle. Current flowing through phase is not same. Neutral is needed. Power losses are more. Now let's find out whatever we have seen till now is correct or not. Whether increasing load on any phase of a three-phase system will make system unbalanced. We'll find that out in MATLAB. So this is our three-phase source, and this little block here will measure the current flowing through our system. The output of this is given to the scope, which will show us the waveform of current. And this is our three-phase load. For understanding purpose, I have made this load purely resistive and equal which here you can see. Let's find out if this system is balanced or not. As you can see, the waveform we have got here is perfectly balanced in terms of magnitude and phase angle. So we can call this system as balanced system. Now let's check out if we increase the load on any one of the phase, then what will happen. Let's also add some inductive power. As you can see, the waveform is now completely disturbed in terms of magnitude and phase angle. And this system is definitely an unbalanced system. So I hope you guys have understood what is balanced and unbalanced system.